In this video tutorial, we shall see subtraction of two 16-bit unsigned numbers. So the logic is almost similar to what we have done in addition of two 16-bit numbers, right? So we shall see the logic as well as the program. So let us first see the logic of the program, right? So the logic remains same, right? First you perform the subtraction of lower byte, right? So whatever the result you get, and then you perform the subtraction of the higher bytes. So I have taken the same number for simplicity, right? So you will get 11H here and also 11H here. But when you perform subtraction, there is one more case, right? So here you can see that the subtrahend is greater than the minute, right? So in this case, whatever the difference we get, that will not be in true logic, but it will be in 2's complement form, right? So if you want to check whether the result what you have got is correct or not, then whatever the 2's complement result you have got, right, that you have to again take 2's complement of it, right? So in this case, what we have got is EEEFH, right? So if you take the 2's complement of EEEF, right? So what is this? E is 1110, right? Then 0. So one more E. At last we have F, right? So this is a case when your subtrahend is larger than your minute. So we get the result in 2's complement form. Something similar to this. So if you perform 5 minus 2, you will get the result in true logic. Whereas if you perform 2 minus 5, right? So whatever the result you get, that will be in 2's complement form. If you want to cross verify, take the 2's complement of the result. You will get to know whether you got a right answer or not, right? So that's what we are doing here manually. So I will take 1's complement of this. If I take 1's complement, so this will be 0, 1, then this will be 0, right? So for 2's complement, you will add this. So what will be the 2's complement now? So if I add this, this will be 1. So other things remain same. 0. So if you see the result, this is nothing but 1, 1, 1 and 1, right? So whether the result is positive or negative, you need to check the carry flag, right? So the carry flag will tell you whether the result was positive or negative. So when you do subtraction, we have to do for both the cases, right? So the logic remains same. First we shall do the subtraction of lower byte, then the higher byte. Okay, let us see the code now. So before that, I am planning to store the 16-bit result in R6 and R7 only. We don't require one more register, because if there was a borrow being taken, then the carry flag will indicate that. Okay, so we need only two numbers, two registers here. Okay, so let's write the code for the same. So first I shall read the lower byte of num1. So this is lower byte of num1. Then I will say subtract a comma 32h. That is lower byte of num2. Right? Here, as a precaution, you can clear the borrow flag. Okay, clear the borrow. Although by default it will be cleared. And whatever the result I get, I will put it in R7. Right? So I will take the higher byte, move a comma 31h, higher byte of num1. Then here I will not clear because I have to subtract with borrow, right? So I will say subtract a comma 33h, right? Then whatever the result I get, I will move it to R6. Move R6 comma A. So this will be higher byte of result or difference, right? So let us see this code. So in memory location 30h, I will store the lower byte. Then in 32h and 33h, the higher byte and lower byte, right? So in 30h, first I will give 22. Okay, first we shall do this. Okay, that is 22h minus 11h. Right? So let's execute and also observe the carry flag. Right? So first I will perform subtraction of lower bytes, that is 22 minus 11. So I got 11. This result I am placing in R7. Then I will take the higher byte 22 minus again 11. It is 11. You can see the result in R6. And most importantly, observe the carry flag. The carry flag is 0. It means what? The result is in true logic and there was no borrow being taken. Okay, that's what we have done now. You can also cross verify in the calculator. 222 minus 1111. Sorry. So it is 111. Right? Now we shall see the other case. Right? So the other case is we are doing 111 minus 22. Right? So the subtrahend is larger than the minimum now. So we will not get the result in true logic now. So I got 1 1 here. Now I am performing 1 1 minus 2 2. You can see the result as EF, and most importantly check the borrow flag. It is equal to 1 now. Right? This borrow has to be considered in the next subtraction. Okay. So I am copying the higher byte. Now I am performing the subtraction. You can again see the borrow flag being 1. It means what? Now the result what we have got, this is in 2's complement form. So I will copy this result in R6. So the final result is EEEF. That is what we had seen. And if you want to verify your result, perform 2's complement of the entire result just as we have done here. Right? And you can cross verify. And you can also check the borrow flag. Right? So we will perform this in the calc. 111 minus 222. We will only check the last 4 digits. So you can see it is EEF. Right? So that's all about the logic and the assembly program to perform subtraction of two 16-bit numbers.